So we're starting to go back here, click on the link for Google Colab descriptive statistics. This will take you to the GitHub page. Should be able to just click on open in Colab. And as long as you're logged into your Google Drive account, it should come up with this screen here. We'll go over the semester. We'll talk more details about how to use Google Colab and give you guys an introduction to Python. A couple things that I like about Google Colab is you can look at the table of contents. So there's a button here on the left that you can show the table of contents. And that gives you a little bit faster way to move around and see what the notebook has. I call this a notebook. Google Colab is a way to view notebooks, and notebooks are a fairly recent innovation within programming as a way to try to make code easier to understand. So historically, you might just get a text file that just has a whole bunch of code in it. And a notebook provides a way to mix descriptive information that looks easy to understand from a human readable standpoint, where you've got headings and things that are highlighted, different font sizes. So this is a nice way to look at this. If you were to double click on that information, this is called Markdown. Not that you guys need to know this or how to edit it, but it's actually, there's a whole set of ways to change this and make it more readable for just people to see. So we've got the instructions. So the key thing here is to click on this shared Google Sheet. And once you're in the shared Google Sheet, go ahead and claim your state, whatever state you want to work on. Hopefully over the next 20 or 30 minutes, we'll get every state covered. So if you find this really challenging and it's hard for you to do, maybe you'll get one state done. If you're finding this exciting and easy to do, maybe you'll get multiple states done. If you scroll down the Google Sheet, you'll see that the previous semesters have done this. So you're not alone in trying to figure this out. In the shared Google Sheet, are you in the Google Colab? Yeah, under instructions. Yes. Yeah, it's the, I think you're in the wrong one. So if we go back to the original instructions, and it's this one here.
Oh,
Yeah. Okay, so yeah, you're in the wrong one. So there's three, but you want to go into the one that in the instructions here. All right, so as long as you're in the right Google Colab, the one we're going to look at here is the abbreviated version. So there's not really a lot of details about the code or how things are working, but you're just going to make a couple changes, run it, and get the results that we'll focus on in our discussion. So once you're in this, claim your state on the sheet here. So all of you should have your name in the data analyst column. That's how you know what state you're working on, and you don't duplicate somebody else's work. This is if you haven't used Google Sheets with 20 other people at the same time. It's pretty dynamic, and as soon as you start typing, everybody can see what you're typing. So as long as the internet connection is working all right, everybody should be able to edit this at the same time. Everybody have a state that you've claimed? Very good. So the information on the Google Sheet will give you the FIPS code for your state, the name of your state, and we're going to look at this for the year 2000. So when you're changing the Google Colab notebook on your computer, it's yours. You have created a copy. When you clicked on that link and you're in your Google Drive, that's your copy. You can break it, change it, delete it, whatever you want to do. If you create some problem and you've broken it, you can just close it, go back to GitHub, relaunch it. So feel free to do whatever you want to in the Google Colab notebook. You're not changing anything for anybody else. You can have fun with looking at the code, changing the code, seeing what happens. Try to break it, and if there's no risk because it's your version on your computer. The other thing about Google Colab is it's actually not running on your computer; it's running in the cloud. So you're going to get I'm not sure if I'm going to get an error message, but everything once you change the FIPS code and the year and you give the state name, all you need to do is go to runtime, run all. You're going to get this message that says, warning, this notebook is not authored by Google. That's, okay, don't worry. I'm not trying to hack your computer. I'm not trying to cause any problems on your machine. Google Colab can be connected to your Google Drive account. And so you can actually use Google Colab to create files, save them to your Google Drive account, read files from your Google Drive account. So it is possible that if you were to run a notebook that you don't have any knowledge about, somebody could, in theory, access your Google Drive account, but I'm not going to have that. You're not going to have that problem in this class. So when I said run all, what you should see suddenly is that you have these little check marks, green check marks next to the code blocks. So this is called a code block. So it's text. It's not text. It's actually code that's written in a correct syntax for Python. Whenever this code block is color coded, so things that have a different color mean different things. So if something is in green, it means it's a comment, and that's something you can read. It's meant for the person looking at this to read it. It's a comment. The program, Python, ignores it, doesn't do anything. Then you have the items in black are, in this case, variable. This is a variable name, state FIPS, equals, and then in the single quotes is 48. So we talked about this before. FIPS codes are not numbers. They're actually text. So somebody who has Alabama through Connecticut, the FIPS code is actually 0, 1, 0, 2, 0. So it's not 1, 2, 3, 4, 5. It's actually, there's a 0 in front of it. So if you have one of these first, Laura, Tucker, Kirti, Noah, Cassidy, make sure you put a 0 in front of the number 1, 2, 3, 4, 5.
Can I ask a question, Professor?
Yeah, Laura?
Yes, sir. When you run the code, if it comes up with just a green check mark, does that mean it's correct?
Yes.
Okay, thank you.
Yeah. So Laura asked after she ran the code, getting this green check mark, does that mean it's correct? It means that it's run. And then if you use the table of contents, you can drop down to the bottom. And if you go to the bottom, you should have 2 tables. And the first table gives the descriptive statistics for total population by census tract for your state. And you should notice, if you've changed it correctly, that I did it for Texas, so I have the word Texas. And if you put in the name of your state, you should actually have that name in the table. And then you can see the total count of the number of census tracts. In Texas's case, it's 4,388. The mean, the standard deviation. Remember that the median is the 50th quartile or percentile. So that's the, it doesn't say median, but the median is right in the middle, the 50% of the data. So your median is your 50% number, and then you've got your max. So you'll need to copy those numbers back and forth between the what you found here in your Google Colab, and then paste them like I did on my example into the spreadsheet. And then the other number that you need is the number of Z-score outliers. So that is this number in this table 2. You have count of Z-score outliers. So this is telling us through the calculations that are done earlier in this notebook, how many census tracts in your state were considered outliers for that year. It should be a pretty small number. And we don't need it for the Google sheet, but you can see the descriptive statistics for the observations that are outliers. All right, so it looks like many of you are having success. The last 2 columns are calculated for you. So once you type in the numbers, the last 2 columns will fill in. So once you've done several states, there's 20 of you in the class. So ideally, most of you would do like 2 states. Again, if it looks like Connor is on fire, so if you can do more states. The other thing to check, you can change the code also, besides changing the name of the state and the FIPS code. You can also change the year. So you can change the year to 2000, 2010, or 2020, which are the different decennial censuses. So here, if I just change the number for Texas to 2020, go back to run all, the code will run for Texas in 2020. And the tables will update at the bottom. So if you remember from 2000, Texas had about 4,000 census tracts. But in 2020, Texas now has almost 7,000 census tracts. So if you change the year, you'll update that information. Once you do that, go ahead and check the previous data analyst's work. You might find that they did it correctly, or you might find that there's a mistake. And there also are some states that are missing information for 2020. So if you want to do it for 2020 for New York, Nebraska, Nevada, Ohio, Oklahoma, those are some of the ones that are missing information. So go ahead and take some time to do this. What we're trying to do is, one, just give you a quick introduction to how Google Colab can be used. We'll look at here, if we have time, we'll look in more detail at the code, and I'll give some more details on that. But also, you're getting to use descriptive statistics for census geography using public data, and then trying to apply that to looking at outliers. So a lot of things going on here, and hopefully we'll all get some experience. So let's look at this pivot table. And this pivot table, I'm looking at the year. So we've got 2000, 2010, and 2020. We can see the count. So remember that census tracts change depending on the size of the population. So when the population grows, the number of census tracts grows. So we'll see here that between 2000 and 2020, they've added a little more than 13,000 census tracts. If we were to do the math and say 13,000 times 4,000, we probably would get a number pretty close to the population increase of the United States. So the Census Bureau is always trying to keep the number of census tracts so that each census tract has about 4,000 people. Now, it's not always the case, and you'll when you did the minimum and maximum, the range, you saw that some census tracts can be really big, and some census tracts have no people, but in general, they have about 4,000 people. And looking at the average of your means, it's about 4,000 people. So that's something to notice, is that it is a statistically determined geography. And this is important because oftentimes we want to look at longitudinal information. So you want to say, how has this place changed from 2000 to 2010 to 2020? And then some of you found this in your earlier application, that you found the census tract for 2020, but you couldn't find the same census tract for 2000 or 2010. That's because the geography changes. Sometimes they don't change, and you can get longitudinal data, but oftentimes when you're looking at census tract information, you can't follow the same place over time, and that can create some confusion. And if you're not paying attention to the changes in geography, you might assume that you can do a comparison and then come up with some weird numbers because you know the numbers don't add up or the counts don't add up. The maximum census tract size, you know, can get very large: 36,000, 37,000, 3,000, 30,000. I think the 30,000 number is Texas. If we were to sort the information, anybody remember if their census tract, if their state had 36,000 or 37,000? Usually Texas wins on the largest census tract, but Texas, California, New York, you know, you'll typically have larger census tracts in areas that are fast growing. And we just as a check, wanted to make sure that all of the information, we have 50 states for all of the observations. So this just a good summary. If you'll, I don't know if you learned this in the LinkedIn Learning Excel course. I think in the Google Sheet course in LinkedIn Learning, they might show how to do this. But to do a pivot table, I went to Insert, Pivot Table, New Sheet. A pivot table is a nice way to summarize data. So you can select different rows, different columns. I think in this case, I have the wrong range set up. So before I didn't have the whole table selected, so I did select all, Control A, and then redid the pivot table. So I did year, so that gives me so in this data, I've got 3 unique values for year. If I want to do the count, so that's the sum of the count. So that's that information. And then I could add other minimum. So like you can change it. So instead of saying the sum, I want the minimum of the minimum, or I want the average of the median. So there's different things you can do with the pivot table that makes it easy to summarize data quickly. All right, anybody find anything interesting about their state or surprising? So let's look at your Z-score outlier. So what this did in the program was it took the mean value, it took the standard deviation, it looked at how many observations have a total population where it was greater than the mean plus 3 times the standard deviation. We can see that in the code. So if we scroll down to the calculating the z-score, so this is a little bit hard to read, but we're calculating the mean of total population. We're calculating the standard deviation of total population. In this case, we're looking at calculating the z-score, which is the population minus the mean divided by the standard deviation. And then we're looking for observations that have a z-score greater than 3, or which is the same as saying 3 standard deviations greater than the mean value. And then we're creating a new variable called z-score outlier that's set to 1 when the z-score is greater than 3. Outliers are very rare. They should be very rare. They shouldn't happen that often. And especially in the case of census tracts, where the Census Bureau is creating a statistical value that's close to 4,000 people, and they're trying to make sure that all of the census tracts have a similar number of people. So it's very rare to find an outlier in a normally distributed data set. So in general, we'll see here that the percent outliers is relatively small. This state is North Dakota. In 2020 had 3.5%. That is a little bit surprising, but it might be a data error, or it could just be that North Dakota grew really fast and has not that many census tracts.
Could it be like the rapid oil growth?
Yeah, so North Dakota has had a large population boom in the last 10 years. So it's kind of there's not necessarily an answer. It's not like there were other states and they deleted them. We didn't get rid of states. But I think, it's important to remember that they're not numerical. They're a categorical value. And for whatever reason, whenever they were assigning FIPS codes, they didn't necessarily follow, they kind of follow an alphabetical order, where you do have, smaller numbers are states that have are earlier in the alphabet, but they do skip states. But that's a good question, and there's not really, I'm sure there's some, if we were to go back in the archives of the federal government, we could find a reason, but the main thing is to remember that you can't assume what the FIPS code is just because Texas is 4.8 doesn't necessarily mean that Tennessee is guaranteed to be 4.7. So it's just don't assume that you can guess what the FIPS code is. Yeah, that could be the case. Like maybe, the United States hasn't always had the same number of states. So it could be that they're adding states, saving room for some state being added would be a good option. And then the FIPS codes also go and include the islands and territories. So that it's not strictly just for the states. Yeah. So that could be a good. Puerto Rico, is there a gap? Yeah, so there you go. So maybe it's future states being added. So so you should see that their z-scores are rare. And if we remember the 3 standard deviations, anything greater than 3 standard deviations is 90, you basically have a 99% chance that everything's going to be within 3 standard deviations, which means there's about a 0.5% chance that something's going to be bigger and a 0.5% chance that something's going to be smaller. And if you look at these percentages, they're, kind of around 0.5 percentage point, 1%. So they're small, which means that the total population for census tracts is a very normally distributed. Another way to tell if something is normally distributed is to compare the median and the mean. If it's a perfectly normally distributed set of data, the mean and the median will be identical to each other. If you have a lot of outliers, the mean will get pulled towards those outliers. And in the case of census tracts, you won't have a census tract with too small, like 0, you have 0 census tracts, but usually the standard deviations, the census tracts are going to be skewed to the right, is what you would expect. So we look at this column on the difference between the mean and the median. This is subtracting the median from the mean. So we'll see here that they're all pretty close. A couple hundred is not a big difference. And they're all negative. So I'm going to scroll down here and see if there's any positive values. This one is quite large. So that's Tennessee. If somebody were to check Tennessee, it might be that these 2 numbers are not correct. And similarly, South Dakota has a very small for its census tract size, but it's possible that Tennessee, can someone check Tennessee for 2000? So in 2000, did Tennessee have a median of 2888? There we go. So 4158. So this again, sometimes if you see something that you're like, that's a big number, you shouldn't expect. So that's sometimes where you could find issues, and Ben, you're the culprit on that one. So make sure you copy and paste. But also when you're doing descriptive statistics, part of why you do descriptive statistics is because you're curious about your data. You want to make sure that the data is accurate, is valid. That's why you want to look at mean, median. You want to look at standard deviation, outliers, minimum, maximum. You don't want to assume that your data is just perfect. You want to play around with it, test it, see what the data looks like. You can think of cases like, say you have age in a data set and you look at the minimum and maximum, and maybe you have someone who's 200 years old in your data as the maximum value. That's probably maybe a warning sign that the data has a mistake in it. In this case, as we're looking down at the difference between the mean and the median, they're almost always negative. So this is meaning that it's skewed to the, in this case, the way we've calculated it, it's skewed to the right. Just seeing if anybody wants to fill in Kentucky, that's the number's wrong because the data is missing. Otherwise, it looks like almost everything is correct. Alaska's actually looks like if those numbers are correct, which they may not be, Alaska would be the only one that's skewed to the left. But that could be because Alaska's has a lot of places that are not very well, not populated. So that could be a reason. If those numbers are correct, then it would make some sense that Alaska could be skewed in the opposite direction.
Say, because I did Alaska for 2000 and it looked fairly normal compared to the other.
Mhm. And then it's possible that Rhode Island might also be skewed slightly to the, not very much, but slightly to the left. So anyway, this is a good example from today of how to use Google Colab. Again, at this point, I'm not expecting any of you to understand the code, but we're going to use Google Colab throughout the semester to do these kind of calculations and do these applications. I like doing it because, here we are in a matter of 30, 40 minutes. We just filled out data for almost the entire United States. Most of you who've never done Python programming or Google Colab before were able to do this. There were a few gotchas, but it works on a Mac. It works on whatever Chromebooks or tablets that people have. You can actually do this on your cell phone, your smartphone. So it's very flexible to use as long as you have an internet connection. And we can see from what we did with looking at the descriptive statistics for census tracts, the relationship between descriptive statistics, census tracts do in fact have around 4,000 people, though that's not always the case. And because census tracts are a statistically controlled geography, the number of outliers is very small. Any questions?